This forms a three-dimensional object known as a cube or a frinkahedron in honor of its discoverer. Hey, hey.
I'd like to announce before I start that the producers of The Towering Inferno, The Silent Adventure, Earthquake...
Excellent summary, Alma.
The rights to my manga.
Perfect.
Trained at Enoteca Pinchioti, Italy's top cooking academy, he never fails to draw raves for his culinary adventures. With
Pertaining can of film was destroyed in a drink-related misadventure in Fulham. It was an idiotic...
But me, I'm a risk taker. That's why I have so many adventures.
That'll do. That'll do, I guess. Good a introduction as any. Hi everyone. Where did... Oh, okay. Yeah, that should go. We don't need that. Or that. Or that. Hey, Arvenla. Okay. Hello. So yeah, normally on stream we're doing ScumVM work, but not tonight, because essentially this is going on. I know I haven't hit, well, I'm not logged in, so it doesn't say join jam, but yeah, there is a game jam happening this month for making new games for our old friend Microsoft DOS. Do you want to call it? Like, what was it called? Like quick? No, it's originally called QDOS, right? Quick and Dirty Operating System. And then it was now just Microsoft Dirty Operating System. So somehow until now, I've never actually made any, like, I've come like halfway to making like something in DOS a few times, and then I kind of got discouraged and gave up. So I'm thinking maybe now's the time. Maybe now's the time that we break through this DOS-based prejudice. So yeah, the categories are pretty broad. You basically just make whatever you want as long as it's either DOS themed or actually written in DOS. And yeah, so the intent, or rather the plan that I have, is to make something that is, something that is pure DOS. In fact, I've written up a little plan on what I want to make. So essentially, what we want to make is an adventure game engine, kind of like how Scum is the adventure game engine that was used by all the LucasArts stuff, and SCI was used for most of Sierra's graphical adventure. We're kind of making something similar, except we can build on the decades of lived experience that happened after that. So in many respects, it should be easier and less painful. But yeah, just to kind of like skim over like basically the aim. So it is going to be made in pure DOS. It's going to be mostly written in, I don't know, we'll start at the top. So aim is we're going to do 32-bit DOS. We're not going to do original Old Testament DOS. That's way too much of a pain in the ass. Yeah, so that would mean building with like, so it's going to be written in C. We're going to build it with DJ GPP, which is like a version of GCC, a popular C compiler. We're not going to use a third-party library for multimedia. So we're not going to use Allegro. We're going to write raw graphics, sound, everything. You know, we're going to write most of that ourselves. Obviously, yeah, borrow where appropriate, but the intent is not to use kind of like an all-in-one framework like Allegro. So that would means for graphics, we are going to get it by just poking at the hardware, like they would in the olden days. But if we play our cards right, we may be able to kind of make that part of the engine portable enough so that we can swap out to be whatever we want. So we can do like VGA, EGA, and then potentially EGA and CGA. I think I've got a couple of ideas how we might do that without having to make new assets for everything. We want AdLib sound, which is the, I guess like the kind of the Yamaha based synthesizer that came, the OPL3 synthesizer. Actually, no, sorry. I say AdLib, really I mean OPL3, so I should change that. So we'll go OPL3, so as not to, because yeah, OPL3 is the one that came after the original AdLib, so we could say AdLib Gold if we wanted to be kind of pedantic about it, but essentially the newer Yamaha chip, which has more voices and yeah, is slightly nicer. Keyboard and mouse goes without saying, so we'll have to write our own code to get to the keyboard and mouse. A serial console will be nice. So like a large kind of, you hear like from, I don't know, when you read about kind of like old development environments, like it was very common to have either like another video card, like, you know, they'd normally have like a VGA card, which is for like the stuff that they were viewing, and then like another Hercules card, which was used just to show like the debugger output and such. Yeah, the plan that I have is we can open up one of the COM ports in DOS, so like COM4, which is not used, and we can use that to open up like a little serial terminal. So essentially, yeah, we make we set up a virtual COM port in DOSBox, we pretend that it is an actual kind of serial cable, and then we plug the other end of that into just, you know, one of these lovely terminals with infinite scroll back and all the other stuff, and then we can be able to do. That just means we can just do things like print statements without them just, you know, messing with the graphics, which would be bad. Hey Summer, good to see you. And yeah, it's got to run. Also, I've decided it's got to run on this. This is the one. I want to say age-appropriate machine that I have left in my collection. It is a Toshiba Satellite 320 CDS. It's got some. The LCD panel has had like
pretty smart for something that resembles a garden cauliflower.
You really think it resembles a garden cauliflower? That's I mean, anyway, we're gonna try and make it run on that eventually. So no cheats, no just assuming that we have like infinite compute. It's gotta run on a Pentium. It's gotta run on like all that stuff. And yes, it is gonna be mostly just me kind of like planning things and just trying to do things on this checklist. So please feel free to just mess with the gimmick system, because that's what it's there for. If not, you'll be entertaining me while I kind of suffer through this. Okay, so we've gone over like what we want to make, but so if I've made this clear from the start, we intend to nick as many ideas from Scum and Grime, which was the engine that they made for Grim Fandango, as possible. So like Scum had, I guess because of like how old Scum was, like there was no easily accessible like what's it called? There was no pre-existing scripting language that everyone could just use. Hey, Funky Mr. Chicken, how's it going? So, you know, Scum made their own kind of bespoke scripting language. I think Sierra did kind of the same for SCI. And then out the other end comes like this bytecode, which then, you know, there's like a custom stack-based interpreter which runs it. That's, yeah. I mean, that's nice and all, but it's also absolutely not what I want to be doing, because we're on a time limit. So ideally, so I mean, like Grime kind of worked around this by replacing the, I guess like the custom scripting language with Lua, which is really quite nice. If you haven't seen Lua, you should absolutely look it up. Hang on, can we go to the Lua site? Yeah, like this is like a Brazilian project which has been around for decades now, and then back in like 1998 or 1999, I guess like one of the engine designers at LucasArts was looking around for a nice and easy replacement for their kind of archaic. Actually, no, like what's his name? Brett Modulewski, who was the I think like the lead engine designer for Grim Fandango, has actually posted like quite, you know, back in the late 90s, early 2000s, posted quite a bit on Usenet and on mailing lists about how they used Lua to make Grim Fandango come alive, or how to make it like flexible enough so that like the designers could spend all their time designing rather than waiting on like engine features to be added. And yeah, it was really kind of eye-opening. I've been reading through like quite a lot of the stuff that he's been writing, And from what I can tell, like, it's actually become a lot easier since then, because one of the features that was kind of missing back in the day when they were like first trying to kind of wire up Lua was cooperative multitasking. So the idea that you can basically like set off, you know, like if you have like a character that like wants to go like have a conversation with somebody, like it would, you know, the nice way of going about it would be able to like just write your script oblivious to what else is going on. So there could be like something else happening in the background, and that could run in its own little thread or whatever while the conversation was happening, and you don't have to, as a designer, you don't have to worry about that. And yeah, that wasn't originally that was kind of a bit half-baked in Lua, and yeah, so they invented like a way of doing cooperative multitasking, which was very clever, but mercifully, like new Lua, that just comes with it. You have the ability to spin up these things called coroutines, which means you can just have multiple things going on, and then they just kind of yield for each other, and they just work, and it's quite nice. So yeah, the intent, yeah. So that is why the intent is basically all of the game logic should be in Lua. Like, if we're writing C, we're losing. It is just going to be... And yeah, no graphical editor. That's just, you know... I don't know. I tend to chafe a bit on graphical editors. So just, you know... And no mystery files. No weird data structures. Everything should either be plain text, or it should be known file formats like PNG, or, you know... stuff that already exists and has good tooling. That just kind of avoids the mess of having to... I don't know, reinvent the wheel too much. So yeah, all of the game logic should be in Lua. The remainder of the engine is going to be written in C, and it's basically just going to be like all of the really... Oh no, I'm not lying. We are going to have PNG. Don't worry. Like, we'll get to that. But we are not going to... yeah, we're just not going to fall down the hole of like writing our own file formats for just storing a bunch of stuff when we could just use text or images or stuff that already exists. Yep, so yeah, we've talked about coroutines, so that's going to kind of affect how we design the scripting engine that's in this. And then, yeah, so just to give you an idea of what will happen, so you've got the C engine, it'll do a single cycle, so a single cycle of the main loop, so a single frame render to the screen would... I guess it would check for like, you know, keyboard or mouse events. It would then, I don't know, maybe based on that, it might put some more coroutines for like, you know, I don't know, walking to an object or clicking, you know, trying to use something on something else. Then it would, yeah, then it would try and finish whatever coroutines are there, which is to say, like, it will try and run each one until it hits like a wait condition or it finishes, and then, you know, just put it back on the stack for later. It would then draw all the sprites to the screen, so we are kind of using VGA memory, which is not very fast, so I mean, initially we can just kind of like hack around it. I mean, it's a big array. You can just write crap to the array and it will work, but maybe for like a second pass, we'll go through and make it so that we only do like, only the areas that have changed have updated. Like, there's many different ways we can kind of optimize that. Hey Mad Moose, yeah, it's probably going to be like a very difficult bingo card this time around. We're not, we are just kind of like kicking off designing a game engine from scratch, and like very few thematic elements are going to kind of crop up, at least in this stream. Like the intent is basically just get it to the point where like stuff is happening on the screen, then we might focus on the actual game part of the game that we're going to design. Like, I have some ideas, but I think I need to kind of like, I need to kind of ferment them a bit off stream before showing them out. Game won't start. Yeah, that'll be an easy one. Yeah, okay, fair enough. But maybe, yeah, keep that in mind. Keep that in mind for later. Yeah, so yeah, do, you know, draw stuff to the screen, fill the adlib buffer. So the way that kind of the adlib card works, I'm pretty sure, is that there is like a first in, first out buffer for putting stuff. like you basically like push registers to the adlib card, and I think there is kind of oh god, it's been a while since we might have to actually look up adlib programming for this, but I vaguely recall there being like you don't have to do the timing yourself. You can get the card to time it for you. Like, so when you like put down a note, you can have some kind of timing interval or some kind of interrupt. I don't know. But yeah, we'd need to do that by hand. Ideally, I mean, we can either do this by hand every frame, or we can have like an interrupt which does it from a buffer. And yeah, and then vertical blanking interval, which is to say, like, you know, to avoid like screen tearing, we can just tell the engine to wait, or, you know, we can force the engine to kind of wait until we reach like a screen update. Okay, so crap that needs doing. This is kind of the part that I got to when I was off the stream. I managed to get the build environment working. So we now have we got here development parenti. So we have an environment here which will build a DOS executable. So if I go source whatever, development djgpp setenv, and then make. So yeah, it will build like this stub that I've put together, and a copy of Lua, the latest version of Lua, and it'll build an exe, which we can then DOSBox. We can then run and see what it does, which is not very much. Mount D here. Oh, okay. No DPM. Oh, right. Okay. Yeah, I forgot about that. So, yeah, because we're doing like protected mode 32-bit, we need an extender, like a DOS extender. When to get a triangle on screen? As soon as we get this, as soon as we get the DOS extender. So you know what? I'm gonna claim, you know, just so no one can claim that we're not being thorough, we'll say that was game wouldn't start because I didn't have the DOS extender there. So there we go. Thank you for keeping me honest. Right. CSD PMI $B. So, yeah, so for people who are not aware with DOS, right, you have, it's basically 16-bit through and through, and for the longest time you couldn't run 32-bit applications because, like, all of the calls to, like, do things in DOS, like, you know, change screen modes and, you know, all the interrupts, etc., like, they all expected a 16-bit, you know, 16-bit calling conventions, and often like real mode 16-bit calling conventions, which makes it kind of even more, you know, more constrained. But later on, then like you have like DOS 4GW, which is like a very popular 32-bit extender, and that just basically provides a bunch of glue, which lets you have like the bulk of your game run in 32-bit mode, and then it provides a bunch of like shims so that if you needed to like, I don't know, like write to the VGA buffer or change some like hardware registers, like it'll do all of the spade work of like converting, you know, downgrading to 16-bit mode, then doing that, and then, you know, proxying the result back. And yeah, so yeah, some compilers use like DOS 4GW or DOS 32A. There's some other extenders. And the newer version of that standard, I think, was called like the DOS Protected Mode Interface, like the DPMI. And CWS DPMI is the name of that extender that comes with DJGPP, or that's like the one it's designed to use. So we're just going to grab CWS DPMI and dump it in here. Huh? Oh, really? I can't just download it? No, it checks. It checks to see if you're using curl. That's kind of... Yeah, I mean, I guess I just got annoyed with people, like, hot linking it. So, you know, that's fair. I can understand that. So we'll just dump this here. We'll dump this here. Unzip, CWS DPMI, CWS DPMI, add CWS DPMI, git add. And if we try this again. Okay, so here's like all we've done so far, which is, oh. So hang on, like, I'll do that in slow motion because you missed like you probably missed like the last bit at the end. So here we go. I've now just moving it down to a crawl. Oh, you can see it redrawing the entire screen because it's so slow now. And yeah, it's basically just kind of like drawing the 16-bit EGA palette to the screen and nudging it over by 1 pixel. Oh, and it was still too quick to see the to see the end bit. So like the bit at the end. Actually, I'll rearrange the code so you can see what was happening at the end. So main.c. So go video shutdown, and that should fix it. Oh, that's right. I got to do it in the one with got to do it in the one with all the stuff in it. Oop. That's my laptop turning off. Source development DJGPP setenv make. Okay. I'll just speed it up because we don't need to wait anymore. But yeah, like you can see that like writing to the entire screen can be a bit tedious. Oh, interesting. Okay. I guess maybe like maybe we need to put a sleep in here. Like if we go sleep 1, like if we wait for 1 whole second. What? Oh, okay. Why is it not, should be printing stuff to the screen. Huh. Oh, that's odd. Well, if I, like, disable the video test... Actually, I wonder, if I'd, like, disable this loop, will that print stuff? Because, like, what's meant to be happening, right, is I've got a Lua script here, which does, like, 2 very basic things. Hello to you too, Martine. Yeah, we're just, we're messing around with this very primitive engine that we've got. So, yeah, so we've just got like some code here which turns on, you know, starts up a Lua state, initializes the video. So this is kind of like entering into the kind of the DOS hardware zone. So we can see video init will load up mode 13H. So yeah, it calls interrupt number 10 with 13, which in DOS graphics mode term is, yeah, it's the VGA 256 color color mode. And then all the test was doing was just writing to every pixel in the VGA buffer with the first 16 colors in the palette, which are always the the EGA default palette, and just, you know, nudging it by 1. But what was interesting though is that I would have thought that like what was meant to happen was that it did like that video stuff, then it shut down the video, you know, it changed the video settings back to normal, then it tried to print some stuff to the screen, but evidently it was not doing the last part. I mean, we could see the text happening on the screen if we didn't shut down the video, which makes me wonder, like, maybe this... Like, I'm not sure what the deal is with VGA and, like, where it keeps the text in memory. Like, it may be slightly different than... I can't remember if it's because I know that like EGA and CGA, they kind of like, they share, like it can either hold text or it can hold pixels. And knowing how you know, big a cheapskate the IBM engineers were, it wouldn't surprise me if that's what's happening, and maybe we're somehow like breaking that, like we're either breaking that, or maybe we're breaking like what the text color is and we can't see it, like something weird like that. Doesn't matter. This is all just kind of, dang. All right, it's not showing. So yeah, it must be the video in it and the video shutdown code that's causing it to break. So if I just comment that out completely, and I go back to here, yeah, there we go. So it'll run the Lua code, which is quite nice. All right, so we're gonna look at the big list of stuff we need to do. Okay, so let's set up the Lua environment, which is tempting. There's set up the serial link, which would definitely, I mean, I'm tempted almost to like go for set up the serial link first, because then I mean, without that, it's going to be like a lot harder to debug, or it's a lot harder to kind of get information out of the engine. Actually, yeah, the other things that we need to do is we need to kind of add in a proper image loader. So initially, right, I was looking into using STB, which is like the single header library for like stbimage.h, which is a very popular kind of single file library that just loads every kind of image for you. The downside of using stbimage, I found though, was that like the thing is though, like, yeah, because we kind of want all the graphics to be like 8-bit, so like with a palette. stbimage does like this thing where it tries to be helpful, and like if you give it like a paletted image, it will just give you back like a true color representation, that like it'll turn the palette indexes back into big colors for you. And that just, yeah, that's way too much overhead, like, because most of the time what we're going to be doing is we want to convert like palette indexes to you know, stuff that fits in VGA memory, which, and you know, we don't need the overhead of like a whole, you know, we don't want to go back and like sift through all of the colors that are in the thing that has been converted and then convert them back to something else. That'd be madness. So the new plan is to ditch stbimage and replace it with a tiny PNG library, SPNG. So we might do that. Let's see if we can put in a tiny PNG library and just blitz something on the screen. That will be the yeah, that could probably be like the triangle test. Mad Moose says ScumVM has many fun paletted image formats. It sure does, Mad Moose, which is why I am not reinventing the wheel. We are absolutely, it is going to be PNG. No, I refuse. You can't make me do a custom image format. Although I say that, like, the one allowance I'm going to probably make is for fonts, because with fonts, there are a bunch of, I don't know, there's basically like a bunch of bitmap, I don't know, like bitmap font formats. They all kind of had trade-offs. And I think my plan is I'm going to go for WFN, which is the font format used by AGS, because I'm guessing that's what most most adventure game people want. There is actually, like, I did find like a cool font that I want to convert into what's it called? Whatever format we use. So I was like looking through this. It's a fantastic website, the Old School PC Font Resource. And yeah, I was just looking through all like the different kind of custom BIOS fonts that were around. And yeah, I found this one which had like a little, you know, it's got like little speed holes in all the capital letters. So I was like, yeah, I want that. Absolutely want that. So yeah, plan is, I think, to convert this to whatever format we intend to use, and then that'll be like, you know, our dialogue font, or our, you know, our overlay text font, or what have you. Okay, so, oh yeah, this is another annoying one. So in DOS, like, one of the big kind of limitations, which I don't know, people who've like played a bunch of like old DOS games will probably know that like the timer isn't very good. Like there is like a fixed timer of like it's like 18.5 hertz, I think it is. So, you know, essentially, if you want to use the stock BIOS functions for like checking how many ticks have elapsed, you only get like updates every 18.5 seconds, unless you go ahead and replace the or like hot patch the timer, which is apparently risky on older hardware because, you know, there's only so many, I don't know, there's only like so much resolution that it can handle. And then of course there's like other code which can call the same interrupt and expect it to be exactly 18.5 hertz, and then that would break. But I was looking around, and apparently there is a way that you can kind of make a shim for the timer driver so that it will run at 1000 hertz, which basically means that we can use that and then get like a number of ticks in milliseconds, which is the same as what you like. ScumVM runs on like, you know, millisecond ticks and the like there. So once we do that, then we don't have to worry about like weird units or like the, you know, the game running at a different pace. Because yeah, like a lot of old games are like 18.5 seconds is like way too, you know, it's way too sketchy. I'll just make it like, you know, I'll make it run every time I can update the screen. And then that's why you have games like Bouncing Babies, where if you run them at like full speed on DOSBox, it'll be crazy fast because it doesn't use the timer at all. It just, well, you know, it doesn't use the timer to work out frame delays. It'll just run at whatever the speed is. So we don't want to fall in that hole. We want to actually get like a nice timer. Oh, Mamu says, practically all games change the pit frequency, don't be too scared of it. Yeah, I know. Like, after a certain point, they did change the frequency. But, I don't know. I've read some horror stories saying, oh, but if you like, you know, if you do this wrong, then bad things could happen. But there's nothing stopping us from just changing the frequency to like, you know, one kilohertz, and seeing what happens with the old driver. Like, it may just completely break everything, but cool. Yep. Yeah, audio driver wise, like, I've been looking around just for, I don't know, like toolkits for like putting together, you know, like trackers, especially for kind of like making ad-lib music. And yeah, Reality Ad-lib Tracker looks pretty good, and they have a player module which is written in C++, but I don't think it would be that hard to turn it into C. So we can absolutely get that sorted. And then, yeah, then it kind of comes down to like more of the, yeah, like, oh, Martine says, I've used RadV2 a bit to make music with. I think I got it, like, I think I found out about it because you posted about it in the Discord that one time, so I was like, yep, that'll do. And also, yeah, if you haven't heard Martine's music, it's friggin' amazing, and like that's not gonna lie, hoping that like some of that rubs off by using the same tool. I know that's a really foolish thing to want, but you never know. Maybe this will be the one time that's true. Martine says Rad V2 supports OPL3. That's really the only difference between V2 and the original from the 90s. Okay, that is good to know. Cause like, yeah, one other consideration is that like with OPL2 and OPL3, I think OPL3 gives you more simultaneous channels, which might be good if we need to kind of augment the engine to support like ad-lib based sound effects. Like, yeah, like I know that like SCI and probably the LucasArts engines, they would like reserve a couple of ad-lib channels just for playing like back sound effect type things. Oh, and it's got more waveforms too. Oh, sick. Okay, that's good. Like, one of the depressing things about like trying out OPL2 after you've tried out like is it OPN2, which is the one that came with the Mega Drive, is that you can only get like two or three waveforms compared to like, I don't know. I'm pretty sure you get more waveforms with like the YM2612 and other things like that. But all right, so that was a lot of talking. That was a lot of you know. A lot of talking, so okay, where are we gonna begin? Okay, let's get the image loading working. That seems like a good place to start. Alright, so very first thing I think is that we need to make a test image. I should probably find like a good tool suited for pixel editing, but in the interim we'll just use whatever we have to hand, which is to say a tool which is kind of mediocre for for making images, but that's alright. We'll make it 64 by 64. Can we change color space? Precision 8-bit integer. Can we change it to... Okay, apparently we can't change it to... Oh, maybe we have to change it to index like afterwards? Yeah, okay, we'll try that. Martin says, oh, so you're making a game in Lua, but it's also going to run on DOS? Yes, so the actual engine is going to be C, but we're embedding Lua inside it, and essentially the plan is to kind of write a bunch of bindings for that Lua engine, so that, I don't know, essentially like the C code should just be sitting there, it should be like rendering frames, it should be like blitting sprites to the screen, but it shouldn't actually be responsible for like any of the game logic. Like all of the game logic, like here's like an example script of how I want it to look. So we should be able to like set a callback for like using an item on the screen that looks something like this. And this syntax here is basically just, again, like I was kind of nicking it wholesale, or, you know, plagiarizing quite heavily from how Grim Fandango does it. So I have here quite a lot of the scripts, like the Lua scripts that come with Grim Fandango Remastered, which you can decompile using dlua, which is a fun little tool. But like if I look here at like, we search for Manny, and then we like look at like here's a good one. So let's open up this, and we can see that this is like the Lua script for, oh okay, so it's like the bit in the forest where Glottis rips his heart out. So it's, yeah, it's a little kind of dense, but we can see here like yeah, so there's like, I think this is the code for like if you put the signpost in the ground, but it is basically like the way that the engine works is that it will have, you know, you can set a bunch of tasks, so you can like say, okay, I want this actor to walk to this point here, and then I want the script to wait until that happens before doing something else. Or, you know, similar here, like you like say a particular line of the dialogue. It's been shortened here to like just a unique identifier, but essentially like you can write this script as if it's the only thing in the game that's happening, and then eventually, well, you can write the script as if it's the only thing that's happening, but in reality what's happening is when you hit this wait for message line, that's a signal back to the game engine to yield and basically just go back to the main loop and do whatever else that needs to be done, wait for the next frame, and then, you know, draw the next frame, then come back and see if this has happened. If not, yield again. So yeah, this is cooperative multitasking that's going on here. And so, yeah, the design for how the Lua script is going to work is heavily based on what they did in Grim Fandango. Hey, Guftron. If I fart and lewd came out, would that make my right arm go numb? My right arm is numb, and I'm trying to work out why. That is an interesting conundrum there. I would say that... I mean, like... I'm not sure if, like, the former has, like, caused you to place your arm in an awkward position where it might get, like, cut off from, like, oxygen or nerves. Like, those are usually the reason why I don't know, my extremities kind of hurt. But and yeah, Martine, Grim Fandango does not use Scum. Yeah, like if you have time to like look up this guy, Brett Mogilevsky, he mentions like, yeah, I started the project thinking that I was going to try and get 3D characters going in the legacy Scum, LucasArts Adventure Game Engine, which had its own embedded scripting language called Scum. I quickly found out that both the engine and Scum were much more special purpose and hard-coded than I'd hoped, and decided to rewrite in 3D with 3D in mind from the beginning. And then, yeah, getting the base stuff replaced was easy. Frame buffers, resources, displaying 3D characters. The question mark was the scripting language. I had no desire to go all the way down to Lexicon parsing yet another language. And about the time, a friend pointed me to the Dr. Dobbs article on Lua. Scum had very forgiving syntax and fairly simple semantics, and Lua's elegant design compared very favorably. So, yeah, it's quite an interesting piece, because it's all about because like by the sounds of it, like there was like a little bit of effort to get buy-in from the designers, but once they kind of, I guess, like cracked cooperative multitasking and they had a few like test rooms up, like it seems to have caught on really well, because Lua is quite nice. There's nothing to be angry about. Martine says, it's honestly amazing that they were able to make so many different games with Scum at all, given that it was really only designed for Maniac Mansion. Yeah, if you look in the Scum VM source code, you can see that there are several cross sections. Like they added like a kind of a layer of extra stuff with each game, and like there are some opcodes which go like all the way back to version 0, but there's, you know, like clearly they were just kind of like adding little bits on every time like a developer wanted something. So, you know, like or just like even just subsystems from other games, like Full Throttle, I know like all the full motion video, and that was just the video engine, the Insane engine, I think was just taken from X-Wing versus TIE Fighter or something like that. Like, oh no, it was Rebel Assault 2. Rebel Assault 2 made the team there made the full motion video engine, and they just kind of stapled it to Scum, which is kind of cool. Oh, Martine brings up like the one Achilles heel of Lua. If it had 0 index to raise, it would be huge. It's, you know, you can't have everything. You know, gotta have a salad. You can't just have ice cream and chips all the time. You gotta have a salad sometimes, and sometimes that salad is arrays that start with the number 1. I don't know. That's, yeah, it's a pain, but then again, I don't know. Excel has it, and it's the most popular programming language on Earth. So who can say whether or not it's good or bad? Okay, that's enough stalling. Gotta do some work now. Alright, image loader. So, first thing we're gonna do. S2B. We're gonna get rid of the image code, because it is not it's not good enough. Git remove S2B image. I'll probably keep the data structures one, because that looked okay, but I might change my mind later. So there we go. S2B is now gone. We're going to add in SPNG. And let's copy in SPNG libspng. Oh, someone earlier in the chat mentioned it should be called ping, so yes. Okay, I'll call it sping. And there we go. It's 2 files. Two whole files. I'll copy the license in there as well, because we want to be above board. Then we got to do some make glue, I think, to build it. Oh, Madmu says they did remove a lot of hard-coded stuff from Scum over time and made more stuff script controllable instead of just hard-coding new stuff. That's good to hear. Like there's, yeah, they definitely kind of like added more. It's just like, you know, like it's an engine that's been around for, don't know, close to a decade. So it's only natural that there would be, I guess, several kind of different tiers of stuff. But yeah, I guess the main thing though is that it is based on like a a compiled bytecode. And Lua is also basically compiled bytecode, except we don't have to write any of that. Which can only be a good thing. Well, we don't have to write any of that, and we get cooperative multitasking for free, so, yeah. I will put up with arrays that start with 1, because I don't have to write cooperative multitasking code. Or, you know, I don't have to write the stuff that deals with all of that. Which, to be, I mean, you know, I get enough of that when I fix director stuff, so, yeah. Oh, no worries, Martine. Thanks for stopping by. Mad Moose says, array indices should start at 0.5 as a compromise. That's a, yeah, that's the true centrist programming language would have arrays that start at 0.5. Much like how, in graphics programming, a pixel starts at 0.5. Okay. What are we doing? SPNG. So that's in here. Now we've got to figure out how to, I know that it comes with like, comes with CMake, and I don't want to include CMake. Because in theory, right? In theory, you could build the entire thing on a DOS PC with native DJ GPP. It just takes forever because it is GCC. It is not. There's a lot of workarounds to make it work on DOS. So that's why we're building it here in Linux, where it's fast. Lib SPNG. Funky Mr. Chicken said, I only just got the notification on my phone that you're live. This is, yeah. I don't know, the Twitch notification hamster is it's been slacking off recently. They've I don't know. I don't know. Maybe all of I don't know. Maybe they've denied the Twitch hamster like bathroom breaks for too long, and it was just, you know, going slow, refusing to work. Oh, that's okay. CMake lists. Okay, what do we got? We've got a bunch of stuff we can ignore. No, this stuff we want. So, we want static. We want to build the static library. We absolutely want to do that. So, we will make it a new one here called Sping? Okay, I just got to remember to call it Sping, and I won't get in trouble. We'll call it lib Sping path Sping libsping.a. Oh, and path sping. So we'll call this libsping make. Actually, no, we're not using makefile. We're just gonna build it with we're gonna build it with CC, like some kind of animal. C flags. C sping dot C O sping dot O. And we're gonna go D. What were the things? SPNG static. Oh wait, is SPNG static used somewhere else? Oh, okay, no, we're just adding in yep, so it just adds in this. Oh, there's a Meson as well. Maybe the Meson is easier to read than CMake ease. Yeah, check see if it's static. This is probably fine. Don't need to worry too much about that. This I think we need to turn off because we need this to run on a Pentium. And I think the Pentium, actually no, look, I can check the Pentium. God, it's heavy. Yeah, okay. So if you look at the little sticker here, it says MMX. That's all you get. You don't get SSE. So unfortunately we can't use that. We cannot use SSE. Oh, that's okay. It's just using a compiler compiler optimization. That's fine. We don't need to worry about that. What's SPNG disable opt? Is that actually something in the code? Oh, and we need mini-z as well. Okay. Yeah, okay. SPNG x86. Yeah, no. We can't use any of these. Look at this. Look at this luxury. Look at all of these kind of fused instructions that we can't use any of that. That would no. We're gonna turn that off. Gonna turn that off right now. So that's whoop, missed that. Yep, get rid of that. Sock that off. Was there anything else in the Meson file? Target clones. Oh yeah, we want to use mini-z. So dspng use mini-z. Yeah, okay. So, mini-z? Yes, okay, I do have a copy of mini-z. Is it checked out to the right spot? Yes, it is. Okay, we do parent source mini-z. Copy the license. All of the C files, all of the H files, and that's it. To parentheses source mini-z. Okay, okay, and we got to do all this again for lib mini-z. I'll say that this also depends on. Actually, no, it doesn't depend on lib mini-z. Like we just needs the headers. We'll just give it the headers. Lib mini-z, cc, c flags. All right, what other stuff is in here? Oh, another Meson file. Okay. Yeah. Right. That seems fine. Oh wait, does it need the Meson file? That could be a problem. What about CMake? I mean, you can make it with CMake. Like, it clearly doesn't need a. You can say. Yeah, okay, so it sets like the version. Oh, like, look, I do not miss CMake at all. Look how much stuff there is for, like, building 3 files. There's so much. Oh, there's so much junk. So much junk. I get that most of it's for, like, building tests and fuzz targets and that, but, jeez, there's just so much. Just so much stuff. Alright, well, let's wing it. We'll go, mini-z. What were all the C files? What are those C files called? These guys. I think you only need, I want to build it in one hit. I don't want to build it individually. And then we go, Actually, how are we building... So with Lure... With Lure, we were rigging it. Yeah, okay. We were kind of relying on that. Okay, that's fine. We don't need to make... yeah, okay. Mini Z I kind of want to make into an archive. I kind of want to. Jeez, I hate makefiles. Madmo says rewrite in Rust. What? Rewrite what? CMake? That's... No, that way madness lies. It's not gonna happen. I suppose... Oh, actually, no. A better option would be to just go, yeah, to do this. So go. Where was some lib mini z? Yeah, path mini z. Because yeah, it works with file names. We can. Good thing there are only 4 files. Okay, so we'll make this a linking statement instead, which will then be like, I guess, all of these. Then it would be, oh, how does this do it? It's like, yeah, so it just does like R.
Thought I told you to fiendishly dice the evil onions! No, sir. That was...
Not the evil onions. Hey, Sissy, how's it going? Oh, jeez. Yeah, we're in the midst of promising far too much for the purposes of a game jam, which is to say, we're trying to make an adventure game engine for DOS. Got a bunch of half-baked ideas on the griddle, but yeah, we got as far as like getting Lure to run in the console. But what we want to do now aim one for tonight, get like a picture on the screen, like an actual picture drawn by me. Because at the moment, what do we got? We can. So if I turn on the video code. Or more importantly, if I turn on the video code and then like build it, we can see the EGA colors move across the screen, but that's about it. So the next bit would be to so yeah, what I'm trying to do is I'm trying to wire up okay, I gotta call it Sping, because apparently PNG is actually pronounced ping. So therefore this is libsping, which is a library for reading in ping files, and yeah, once we get that sorted, then we'd be able to kind of like load in an image and like splat it into VGA memory. MC says, I would play the game as is. It's already better than a lot of games I play. I don't know, I saw that like the Contraption game, like that was in all CGA. That was pretty impressive. I was quite that considered my socks knocked off by that game. But yeah, the key though with that, right, is that if we do all this work, like I'm avoiding using Allegro. I'm trying to kind of just use like hitting the hardware up, because if we do that, right, then we can kind of do like, we can do nasty things like get EGA and CGA mode working. We can rig it up so that like, you know, you make like one version of the, you know, you make your version of the game with like a nice color palette, and then you can make another version which uses the EGA mode, which then like converts the colors for you, or you can give it hints as to how you want to convert the colors to. And I figured like that would be like popular with a small group of people. Important, you know, an important group of people. I myself would consider I myself am part of that group, but yeah, like that by itself would make it more appealing to me than AGS for making a game in DOS. Okay. Mad Moose says, I'm excited for you writing your own Bressenham line drawing. Oh my god, really? That's right. No, but no, I don't have to despair. You know why I don't have to despair? You know why? You know why? Because of this. Because all the crap we need is in here. Like, all of the answers are, you know, there's money in the banana stand. You don't have to write like I'm not going to write my own pathfinding. That's like, you know, that's crazy talk. What I'm going to do is I'm going to go to Scum. I'm going to look up how it does. Like, I'll show you how like pathfinding works in Scum, because like one of the things that kind of like really irritated me about like some adventure game engines, AGS in particular, is that the pathfinding, I don't know, like at the time I used it, the pathfinding was kind of annoying and not great. So let me show you what Scum does. So if we go to like what's it called? The thing. Scum VM, Fate of Atlantis. I think Fate of Atlantis should show this. Indiana Jones and the Fate of Atlantis. Scum VM Atlantis. Unrecognized game Atlantis? What? Come on. Really? zgrep Atlantis. Scum Atlantis? Huh. Don't know why that is. Sorry, what? Dopamine Machine is trash. You can say it. I'll say it. I said it. Like, what's trash? I missed an important part of the conversation. I plead ignorance. Anyway, so we'll just we'll get. Oh no, that was too far. That was too far. I actually just wanted I wanted the first bit. So like, I don't mind the pathfinding in Scum. I think it's alright. So, here we go. We'll walk on here, we fall down here. This room here I think will show like a pretty good idea of how it works. So, skip all of this. And then we open up the debugger. And we draw box. So you can see here, like, so in the Scum code, you've got what's known as walk boxes. These are basically just kind of like quads. So like, you know, shapes with 4 corners, and you can basically just place these anywhere on the floor. So, and if I close the debug console and move Indy over here, so it's kind of out of the way. Box. So you can see here, like this is the walkable area on the screen, and it actually, yeah, like it works pretty well in terms of like being able to get from one area to another. So what happens is if I click like this, if I click this point over here, what will happen is that the Scum engine will look at all of the boxes. It'll make a chain between all of the adjacent boxes, because there's like one box here, and then there's another long and thin box here, one over here, etc. And it will kind of like, you know, make a nice chain between them. And that's how it knows how to kind of like hook around and go to this point here. And these very thin lines here, they're also boxes. They're just kind of like 1 pixel wide boxes. But they work, like, because there's, you know, because it's kind of like in coordinate space, so there's like, the box starts here at this pixel and ends at that pixel, and then another box starts from here to here. Like, the engine still goes, yeah, that's fine, you can walk on that that 1 pixel line. And that's what makes it much nicer than what I remember of how AGS does it. AGS just allows you to, like, you know, paint on the screen. You know, it doesn't use kind of boxes. It just lets you just paint freehand, and then it tries to kind of like guess the, you know, guess the shapes out of it, which is kind of a bit, I don't know. It's kind of sketchy, and it doesn't work more than it should. Which box connects what is completely manually set though? Oh, really? Okay, that's kind of annoying. Really? Like, I thought this was just kind of the box data here. Like, it just shows a bunch of boxes. Like, is there like a connection parameter that I'm not seeing? I thought that it just iterates through trying to find like the nearest box to the next one. I don't know. If that's the case, then maybe we're gonna have to like change a little bit. But I do like the idea of there just being kind of regions that you can mark up, and then, you know, it wouldn't be too hard to just kind of, you know, use Inkscape or something like that to get the coordinates that you need to do the walkable area. Or maybe there'll be a way of like doing it in the engine later. But yeah, I don't know. I quite like this option. So anyway, that is a lesson on walk boxes. Gotta get back to the boring stuff, which is struggling with make. Okay, so we'll do one of these, except we'll go mini Z. Oh, sorry, not path mini Z. Yep, so build one of those. That then depends on all of those, so that should... Okay, and then we got to change this line here so it actually builds the library with R. Yeah, that should still do that. Oh, Madmoo says there's a walk matrix that says if you're in box 3 and going to box 7, go to box 4 first. It's my understanding that those are made manually. Interesting, okay. Interesting. I don't know. I reckon I reckon you could cheese that. I reckon that like just the knowledge of like what boxes are closer to each one's, like you could use like Voronoi distances or something, and you could cheese that. Like how bad could it be? But I don't know. I will be looking into the walking code in my own time to see how we do that. Okay, cross prefix. Oh, that's right. We can just look at the other makefile which does it for us. Yeah, okay. I'll pretend I know what that means. Yeah, we'll see what that does. Make, oh sorry, gotta do GJGPP. Env. Oh, set env. Make mini Z. Is it mini Z? Ooh, all right. Maybe. Okay, so this was the thing that was being generated by what's called Meson, the build system. So we got to find a yeah. So we got to find a thing for that. So mini Z. Config config file, mini-z export, okay. How about if I'm just going to build this here. I'm going to go Meson build. What's the trick for Meson? Or is it Meson setup? Cat read. I can never remember how to run Meson. And it's not going to tell me. Meson. Oh, okay. Must have split. Okay, Meson build. Okay, there we go. And what's in here? Okay, nothing. But that's fine. What is mini-z export? Like, why should I care? Okay. Well, that's fine. We can go build mini-z export. I'll copy that to... Copy that to here. And... Oh, that's right. No, we've got to... It's something else. Oh, Manmoose could say, I can speak at length on Blade Runner's walk boxes. I even made an ASCII diagram in the code. I'm available to hire for tasks. Well, if I get pressed for time, like, I'm not above paying my way to get out of a deadline. But, I don't know, how did you find the, like, I've not played Blade Runner. Are the walk boxes any good? Like, a large part of that, like, the game kind of struck me as ambitious but flawed. And so I'm wondering if that also applies to, like, very basic movement, you know, stuff like moving around. Hang on, Pragma. Using Fopen, this path may not support large files. Don't care, we're not going to use large files. What did I try and do? Oh, okay, so I was trying to do R. What are the options for R? They're, oh, yeah, okay. That's right. So, we gotta do RC. Make mini-z. Make mini-z. Why is it still making it each time? Where is it, Oh, it's crapping them here. That'll be why. Oh, because it's not doing -O. It's not doing -O. Okay, get rid of that. Gotta do this properly, right? Oh, it's because... Yeah, it's because of my sloppiness here.
Beyond belief. Fact or fiction?
Hey, crushing ceiling. Actually, yeah, did Frakes have anything to say about,
Ever gone mountain biking? Bikes like these are not only great exercise, they're made to go over rough terrain, hills, gullies, and streams, wherever the adventures lie. Peter...
Yeah. This is rough terrain, alright. Making stuff built for DOS. It worked is the resounding praise when it comes to walk boxes. I know, right? It's rare. It's remarkably rare, which I think is why so few kind of like smaller game engines manage to do it good. I don't know. I'm just thinking of like Sonneveld's recent stream where he was playing Future Wars, which has just a god-awful movement engine that expects you to be pixel perfect. Yes, I don't know. I have a soft spot for Delphine, but their early games had terrible movement, and some might say questionable gameplay. Okay. Hang on. Make file syntax. rather than me just kind of guessing what the symbols mean, I should probably just, because I know that like at I think is, oh okay, no, we can work this out by induction. $at must be the target, and these must be the dependents that are up there, I think. That kind of sounds right. So if we go dollar question mark and then $, will that work? Will that crap it out in the right spot? Make mini Z. Look at that. Okay, didn't even have to check for a hint. It just did it. Okay, but we now have, more importantly, we now have lib mini Z, which means we can, how about make sping? Okay, it's whinging that it can't find mini Z. That's fine. That's on me. I did not tell it where to get that stuff. We need to go, path mini Z. Do I have like a list of include places? No, I don't. Okay, well. Oop. Alright, and it built that too, which is good. Alright, getting there. We're absolutely getting there. Okay, so we've built Sping, we've built mini Z, which means all we need to do now is link it into here. So we can go, we want lib lure, we want lib Sping, we want lib mini Z. Actually, what have I got as lib Sping? Oh. Well, we can do what we were doing up there, I suppose. We can make it so you go this lib mini Z path sping. There's only one file that we need to build, so it's not the end of the world. And then we make a little archive with it in. Okay, so we've done that, we've built this, we've added all of those in. Up here we need to go in and add in library locations for all of these, lib sping, lib mini Z. Okay, and make clean. Oh, wait, I'm not in the right spot. Oh, what's it whinging about? I mean, okay, it made one of those. Cannot find, we've got lib mini Z and we've got lib spng. Is it because, like, oh god, alright. I ran into this before with Lua, and I can't remember how I fixed it. It is kind of annoying. But I thought it was, yeah, I thought it was to do with, like, the order? Like we have, C flags, objects, LD flags. Like, the trick was you have to put objects at the very start, otherwise it won't work. But it should be clean. Is it? Okay. Make dist clean. I'm just gonna close that. I keep getting tricked. What? What do I call it? Oh, whatever. Good enough. Make. Okay, so we made... So I made the Lua one, okay. What are we doing differently from all these other cases? So, yeah, we're combining all of these object files into an archive. Then we're calling ranlib on it, which should give it the, you know, the seal of approval to make it real. And then it can't find it, despite the fact that... Oh, right, it's because I'm including the whole path there. That'd be why. That's a mistake, yeah. So it should be path. Spring and path mini-z. I think that'll... Yeah, there we go. Okay. So we've now got a PNG library in there, which means we need to make a test image. So I'll say oh wait, no. We want a hard edge. Like that, yeah. Whoop. Not quite. Oh, hang on. If I make it better. There we go. Let's add some other colors in here while we're at it, so we can test. It doesn't matter which colors that I give it. It's just going to be whatever the... We're not going to change the palette just yet, so it'll be whatever is at the start of the EGA color spectrum. So we'll take this image, we will transform it to index mode. Do all of that. No color dithering, please. And then palettes? Where'd the palette window go? Ah, here it is. So there we go. We've got 4 colors. VGA default palette. Now we might have to like kind of move it around so that it is visible, because I think the first few colors are grey. Yeah, okay, so it starts with like black, dark blue, green. So in order for this to be visible, I think we're going to need to... Actually, no, we can add another color, which is like down here. And then use that with the paint bucket. Oh wait, did that make a new color? Okay. Oh no, that's just using whatever the background is meant to be. Okay. But I want to make another color. Come on. Ah, there we go. Okay, we'll make this amber. And then we'll change this. I think we're... Oh, and we'll make another one, which is... Yeah, okay, so we'll make this this color index the one that's used for DOS. We'll change this to a different color, ideally. Something that isn't used, so we can at least like block out that bit of the palette. There we go. So export as games. Oh no, not games. What am I saying? We'll call it test.png. Let's be imaginative here with our naming. Yeah, automatic pixel format. We want 8 bits per color, RGB. You know what? Let's leave. We'll put compression in there just to make sure that the library can deal with it, because ideally I don't want to have to worry about like making special pings which can be read by anything. I just want it to read stuff. Okay, and now we've got to look up SPNG. Features, security, testing, document, docs. Want some docs. Okay, usage. So what we want to do, right? We want to be able to ideally like screen it. So before we load the image into memory, we want to check to see if it's the right format. Hopefully there'll be an API for that. Like what do we got? We've got, okay, so it creates a context. It sets an input buffer. Interesting. It generates how big the... Oh, okay. Does it load? Like maybe buffer is like data that comes in, or is that decode image? Hang on. Let's look. We'll open up the API documentation. Decoder API. So what we got? Oh, this is... Yeah, okay. Examples for encoding. Don't really care about that. Okay. Okay, error handling. Boring. Memory will always use a context buffer. Chunk count limit. Okay, it looks like there's some kind of buffer that we need to set up ourselves, to like, so that we can like, I guess, load in the image like one bit at a time. I will defer to the example code for how to do that. I mean, like, there's encode image, which I don't care about. Okay, so it reads a PNG, creates a new context. That I understand. That makes sense. Let's just look at the API docs. Common? Oh, okay, right. So, yeah. Ignore checksum and deflate stream. Okay, so we don't need to set any flags. So, open up our main.c. Oh yeah, this can all get in the bin because we're not doing that anymore. This was the point at which I realized that, like, when I was trying to use STB to load in the image, like, it is quite nice and elegantly simple, but yeah, it does not give you palette mode access to anything. It will convert it all to like fat 24-bit color for you, which unfortunately is not what we want. We want everything to be palettes, which reminds me, I should probably check to see that the API here also supports palettes. Would it be easier if I just like went to spng.h? Index. Okay, there's index color, row info. It'd be really funny if I like got this far loading in this library and it turned out it also did not support palettes. But it's got it right. Is that what G8 is? So those are just like generic PNG options. Don't RGB. Okay, it does support RGB8. Oh no, wait, that's RGB8 per channel. That's not the same thing though, is it? What are they like? Okay, decode image through an explicit output format, e.g. 8 16-bit RGBA from any PNG format. With SPNG format PNG, the pixel format will be identical to the PNG's format in host endian, or big endian with SPNG format raw. The latter does not support any transforms. Okay, the pixel format will be identical to the PNG's format. So what I'm hearing from that is I should be able to get just raw colors. It should not be trying to... Okay, so I get it. So what you can do, right, is you can say, I would like this translated into RGBA, please. Or you can give it SPNG format PNG, which will just keep it how it is. So, but really what we want to be able to do, right, is we want to be able to kind of check to see that is the right, that it is 8-bit. Well, there's RGBA 8, RGBA 16. Yeah, look, yeah, that's, that is what I'm kind of looking for. Unfortunately, the documentation is a little sparse. I am maybe regretting not getting all of, just getting libpng, because it is LibPNG is 4 times as big though, compared to this, which does chip at me a bit. PNG chunks. Maybe it'll help if I kind of like know what the chunk in the PNG is called for palettes. And then we can work backwards from there to figure out how to get it from oh no. I clicked on this. No. God no. It's the opposite of what I want. PNG file chunk inspector. Okay. So if I give it, like, the lovely PNG that I made, there should be a palette chunk. And that chunk should have a name, which I should be able to look up in the library. Yeah, Parenti test. So what do we got? We got a file signature. We got some image header, which says 8 bits per channel. Physical pixel dimensions, date. Okay, there's the there's IDAT. Where's the palette? Is it it's not here in the ICC profile, is it? Yeah, like where's Pult? Where did Pult come from? Is there no Pult? Is it just not there? There is no Pult chunk. Okay, for color types, the Pult chunk is optional, provides a set of colors. It is, however, recommended that the Spult chunk be used for this purpose rather than the Pult chunk. Note that the palette uses 8 bits per sample, regardless of image bit depth. In particular, the palette is 8 bits deep, even when it is a quantization of a 16-bit true color image. Okay, there's a transparency chunk. Image histogram? Suggested palette? I mean... It's not an ICCP, is it? It's not, because, I mean, there's no... I can't see any colors in there. It's either got to be that or like IDAT, right? It's got to be in either of those, but yeah, okay. That's just like the color profile. Don't think it's got anything to do with the palette. God, all right. Okay. Is this the... Okay. Decode image. And of course, yeah, right. Pre-processed palette in image, yeah, entries. Oh, okay, so it's just, yeah, it's there on the context. So presumably if we load the image, it'll do all that for us. Okay, let's take it as read that we can check for that. What functions we got? We've got setting a bunch of chunks. Don't particularly care about any of those. We can do a bunch of get stuff. We can decode the image to a buffer, which is probably going to be useful. We can set the PNG file. Okay, that's probably good. Let's just try doing some stuff. We're gonna do some stuff. So include so we're opening the image. We're going to SPN CTX equals SPGN CTX new. I'll say 0, which I think means don't worry about compression or anything like that. We'll then do CTX set file, and that will be FP, which is our oh, and you got to give it the context, of course. ISO C99 later do not support implicit. Hang on. Oh, set PNG file. Okay, so we've got that, and then we can do. What do we got? We've got like get PNG buffer. We've got get image limits. We've got get. Yeah, maybe we want to do. We'll do get image limits. SPNG get image limit. And then we'll just go printf. Path this width, this height, this. Right, okay. So very, very, very basic to begin with. So we'll turn off this video blitting code for now, because all it will do is break text output, which we don't want. Turn this off, and oh, and we gotta add one of these, which would be how did I do it for this one? Yeah, okay. And then we just copy this, which is our test function. And now we can include image.h, get image test.png. What? Undefined reference to get image. Oh, because I didn't build image.c. That'd be why. Because I needed to add it to... Oh, here, okay. Failed to open image, okay. Oh, because I didn't put it in the right spot. Test. Did I? Hang on. Okay. Good, okay, good start. We've got some nonsense. Is that gonna be -1? That strikes me as being -1. F. Maybe it's half of -1. 8 0 0 0 0 0 0. Okay, it's okay, not quite. So it'd be 7 F. Yeah, all right. So we did something wrong. We did something wrong there. But what could it be? Just... I don't suppose this thing would have like a nice error function, would it? Maybe not. Okay. What are the docs for get SPNG get limits? Okay, get image width and height limits. Width and height must be not null. Maybe the clues in here. Get image limits. Oh right. Okay. It doesn't. Okay. So we were just reading we were reading uninitialized memory. So it just returns 1. Oh, so we should just be checking to see if it returned anything before we continue. But yeah, if the context is null or if any of these pointers are null, then it will bail out. That's okay. But the context shouldn't be null because okay, maybe it is. Maybe we should put in some error checking. So we'll go if ctx printf return create png spng context. We should probably also check to see if there's a set PNG file. Printf failed to set PNG file. Return. And we should also clean up after ourselves, which would be spng. What's the free command? tx free cdx. And then we do it one more time down here, which is if this didn't work, Actually, I think 1 is bad, right? So, yeah. 1, yeah. 1 is the return code if it's bad. So, we'll do this. To get PNG image limit. Okay, there we go. Now with memory safety. Huh. Okay, did rebuild image at C. Did do that. I'm probably, yeah, also before I forget, I need to change I need to change this here to be better. There we go. I mean, it's doing it. It just thinks that it's just the width is just not correct. Like, none of that is correct. Oh, okay. Alright, no, that's right. I was about to go, oh, I wasn't passing that in as a pointer, but we are. We are passing that in as a pointer. It's just that, I guess whatever the defaults are, the defaults must be... Defaults must be just kind of slightly weird. Get... Huh, okay, maybe they're not actually, Oh, we have to read the... I think we have to read the header first. Is that part of the API? No, it's not. Read chunks? Oh, decode chunks, okay. Okay, let's do that. Let's decode the chunks. If SPNG decode chunks CTX printf. Okay, better. So we know that the problem is that we can't decode those chunks. And oh, but there are multiple recurrent codes, so we really should be printing that. And it's all int as a result. So we'll just say int result equals 0. Result equals this. Result equals that. I think you can do this in USC. Using the result of an assignment as a condition without parentheses. Okay. So I think we can do it. It's just shaming me. How about now? Look, I put an extra set of brackets. Are you happy? Am I no longer running afoul of the law? Okay. So error code is -1. Which is gonna be E context type. Huh, okay, so It's IOEOF. So what's going on? So it's trying to read the chunks. Like, it looks like the error code that it's running into is IOEOF. Oh, and it does have like a nice error code function, so we'll do that. That'll really cut down on the misery. But why is it saying end of stream? Like, is it because, like, what operation we done? Like, all we've done is we've opened this up, and then we did set PNG file. So what exactly does set PNG file do? Yeah, okay. There is like this read function and this write function, which look interesting, and there's also get PNG buffer. Maybe we should cheat. Maybe we should just check for. Okay. Alternatively, you can set an output file or stream with set PNG file. Okay, no, the very first thing we need to do is get iHeader. So we'll do that. Because that's what the example code tells us to do. Before we decode the chunks. Again, it's just end of stream. Is it because it's opening it in write mode and it's expecting like to be at the end of the file? Is that an option? Yeah, it's okay. It's still PNG, so it's not clobbering it or anything. But oh, what? Oh, maybe. Oh God. Oh God. Is it because of that? Is it because it's trying to load it in text mode? I forgot that C allows you to do that. I thought it was just Python. Where, I mean, in Python it's actually useful because you get like a different structure, but yeah, that could be an issue. Well, we got further. We fetched the iHeader, so we didn't run into the initial issue that we were having, which is that we were just slamming into the end of the stream when we tried to decode the chunks. So that's good. What's in the iHeader? What can we get out of it? Oh, all this cool stuff. We can get all this cool stuff out of the header. Like, that's basically what we wanted. Not the image limits. Like, to hell with the image limits. Like, get rid of all that. Get out of here. Oh, is that a... Oh, that's a... Is that a custom function that they did? Yeah, it is. Okay. Don't care about that. We can make do with the number. There we go. Look at that. All right, so we've got... Yeah, so we've got the image dimensions. We've got the bit depth, which is 8, which is good. No, I think bit depth is referring to, like, how deep each channel goes. And then color type is the one that's referring to whether or not it's, like, a paletted image or not. Let's check. Let's just double check. Because it's, okay. What do we got? We've got width, we've got depth, we've got bit depth, we've got color type, which is not typed. Oh, okay, fine. We've got compression method, we've got filter method, and we've got interlace method. So, yeah, right. SPNG, okay, so we want to check the SPNG color type indexed. Because that's our guy. And we'll go if IHDR color type is not SPNG color type indexed. Image S is not an indexed. Is not indexed. Not paletted. Yeah, okay, and then we don't need to free this up because this is just on the stack. This is just having a little fun time there by itself. That'll get freed up when we leave. But we do need to free the context. And then just move this here. We'll go path there. And there we go. Then after that we should have our image, which then means... Okay, so for the purposes of this test, we just want to be able to, like, we want to be able to write it to the VGA memory. So that means at the minimum we need to get the data, and we need to get the width and the height. Sorry, ideally we get the palette too. So we get the palette, the image, the width, and the height. And if we just assume that, you know, the bit depth is going to be what it is going to be what it is. So what we've got two options. We can either, like, drag out, I don't know, we can either, like, spit out whatever Sping produces and just say use that, or we can create a new struct. Let's create a new struct. Struct image. And we'll go type def byte unsigned car. And then we'll go byte image. Okay, we'll go int32 width, int32 height, int32 pitch. Yeah, pitch is useful to have because essentially, right, when you have an image that's like that's like weird sizes. Like we're talking like, I don't know, like say you got like a 10:7 image. So it is almost always quicker when it comes to like indexing to do it with powers of 2. So a nice kind of trick to get around that is, I don't know, if you have extra memory, is just to instead have this pitch, which acts as kind of like the width of the, you know, the width of the array. So like, you know, this data here is like a block of memory, which is going to be, I mean, like normally it would be like width times height bytes, but because we want to kind of get that advantage of like aligning to base 2, we're going to have it as like height times pitch. And pitch is going to be like the next power of 2 after, you know, the next power of 2 rounded up from width. So there, you know, there is like a little bit of memory overhead from that, but I'm hoping that it will make it quicker to blit things. Like maybe I'll regret that decision later, but that's okay. We've got, okay, so we've got all that. Do we need anything else? Palette, that's right. We need palette. So we'll say byte pal data or palette, and then we can, I don't know, for now we'll assume that it's like exactly 256 times 3, because that's what it would always be. Yeah, okay. So we have our crappy image struct, so we'll go let's go struct image create image, and we'll take that SPN, you know, we'll change this to create image, and we'll make that struct image returning a pointer. That's right, it's C, so we just return. Is null pointer? No, null pointer isn't a thing. It's just return null. I'm thinking, yeah, I've got C++ brain. That's my problem. Okay, done all that. Return, and then we'll go. Yeah, right. Okay, we're good. So now that we have all this, we can go struct image equals struct image malloc size of struct image. What do you mean incomplete type? It's very complete. It's oh right, because I didn't include the H file. That's fine. Image.h. There we go. Okay. So firstly, we allocate the memory for the struct. Then we allocate the buffer. The buffer's inside the struct. So we go image width is going to equal ihdr width. Image height equals ihdr to height. Image dot pitch. It's going to be ihdr width. What's the best way to round up to a power of 2? I'm sure someone on the internet's done this. Code round up nearest power 2. Oh, yeah, true. We can use the left shift. We can use the left shift operator. Oh, jeez. All right. Surely there should be a way of being able to do it with shifts. That's okay. There's some kind of weird iterative solution, but really, there's no way of just saying, "Oh, that's the top bit. Let's." Oh, okay. There we go. A blog post. Someone will have spent far too much time thinking about how to do this, and I can lean on them. All right, how do we implement this power 2? Check all the powers of 2, stopping the next one which is big enough. Okay, maybe you do have to take an iterative approach. Maybe you do. Oh, but there is a GCC extension which does it for you. Here we go. The B square instruction is bit scan reverse. As usual, there is literally no official documentation on this instruction. Isn't that nice? Isn't that lovely? Well, we are using GCC, so we could just get away with it. We could just do it. Like, there's, you know, we could risk going to hell. I'm curious now. I want to see if it works. Oh wait, the down. I mean, this would be implemented for other platforms. It wouldn't be just using the I mean, here it's just using the instruction, but I mean, like ARM, for instance, built-in Kurzweil ARM. Okay, is it available on ARM? No, okay. Looks sketchy. Looks sketchy is what I'm reading from this. Okay, maybe we have to do it right. Maybe we have to do it right. Which is to say, like, there's only a finite number of... Okay, we can just do... We'll do it quick and dirty. Okay. Int... get pitch. Uint 32. T... width. And then we'll basically just go for I... int I equals 0... I is less than 32 I plus plus. And then we just basically go if width is less than I or 1 to the power of I. What are we looking for? We're looking for the point at which 1 to the power of I is either greater or equal to the width. Is 1 to the power of I is greater or equal to width. Return 1 to the power of I. Or sorry, 1 shifted to the left I times. I should really say. So yeah, this basically is like, this is equivalent to 2 to the power of I should say. So if I is 0, then the answer is 2 to the power of 0, which is 1. I is 1, that is 2 to the power of 1, which is 2, and so forth, and so forth. And then we just want to check to see if, for the next biggest number, which is greater than or equal to width, and then go to that. That's fine. We're not going to be doing this function, like, awfully long, so we'll just go get pitch from the width, image data equals byte malloc size of byte time. Actually, we want calloc, don't we? We should be using calloc. Like, malloc is kind of, like, messy. Malloc doesn't, like, reset the memory. Yeah, okay. We'll be good. We'll use calloc. And then we'll go this, and then it's image pitch times image height. That should... Did I not, Oh, right. Byte. Got around the wrong way. There we go. So... That's done, image palette equals uh, 256 times 3, and we'll go size of byte. Okay, there we go. We've allocated like all of our memory that we need for this. Now we just need to kind of copy all of the crap from the PNG into there, and then we can start splitting stuff on the screen. So I remember there was a function there called like read rows. Like that strikes me as like a nice kind of don't use too much memory approach to doing that. Is there a rows? Rows. Yeah, decode row. Oh, there's like decode scanline and decode row. I think we want decode row. Where did, Okay, so there's row. Oh, I see. Right. Okay, because like this is also like down to the way that like PNG files are stored, right? You can store it as like an interlaced image where it kind of like downloads like one set of fields and then it downloads the second set of fields like interlaced. So in order to kind of read the file from start to finish, that's why it's got like this row function here. So we need this in order to kind of be able to like jump back and forth in our output. So yeah, that makes sense. So we'll copy what they've done here and just do a little modification. So I missed out like the okay. 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 So here's the tricky part. We've got to give it decode row. Right. Progressive decoding is straightforward when the image is not interlaced, called SPNG decode row for each row of the image will yield the return value SPNG EOI for the final row. Okay. Yeah, this is the stuff. Okay. And we've got our image width, image size. We'll keep doing it kind of progressive like. Yeah, okay, and then like that's this row pointer here. So if we go byte row equals image data plus image pitch times row info row num. Okay, so this gives us the starting point in our data array of where we need to load stuff. And then now this stuff just goes to row and width. And then eventually, like when we hit that, Oh, and I should be putting like file pointer free things here as well. God. Temptation to use goto is quite high. I'm not gonna lie to you. Do we actually no? When we do set PNG file, like, does that should give ownership to the SPNG thing, right? Like that. I don't know. We won't worry about that for now. We'll just pretend that everything is okay. Because, like, I mean, we can check, right? So, set PNG file. Oh, okay, yeah, no, it doesn't take ownership. I don't think it does it anyway. So we gotta clean that up. Which means we gotta clean it up in all of these spots. And then, yeah, temptation to use goto is high, but maybe after we've sorted everything out. Return image. Oh. So, okay. Done all of this. Oh, I gotta put in the three thing in here. But that's looking good. That's looking good. Actually, yep. So we've got all of that. We're gonna go void destroy image struct image. And this will be the equivalent of freeing it. So free. So we do that last. And then free data, free palette. Oh, sorry, image. Okay, we've done that. So going back here, we can now do create image. Right, so this should be, we should have our test image data. So now all we need to do is go back to DOS, and put in void video blit image, and we'll go struct image int x, int y. What? What is it even editing? Jesus. All right. Conflicting types. I mean, they should be the same thing. Oh, is it because I didn't, Oh, sorry. There we go. Okay. Now, VGA. It's dumb as rocks. All you have is a big chunk of video memory, and you write to it in the colors that you want. There's kind of like smarter ways of going about it. Like you can turn on Unchained mode, which gives you access to like 4 times as much memory, or I think it's 4 times as much. And then you have to kind of like worry about when that happens. You have to worry about like multiple planes. So like instead of having like each row of pixels next to each other, you've got like 4 planes next to each other. So each pixel, there's like one for each of the 4 planes, which is not, I mean, you're already doing kind of like bit shuffly type things to get at to write to VGA memory, so it's not the end of the world, but for now we'll just use it in dumb as rocks mode. Okay, so we've got our image, we've got all this. We'll ignore the palette for now. We'll just try and blit what we have to the screen and enjoy the horrible colors. So we'll go for int y equals 0. Oh, actually, we're gonna have to go like yi equals 0. Yi is less than image width or height. And yeah, okay, so we'll have to actually no, we'll be smart. uint32t width is going to be, it's going to be this, but we have to also take into account that the screen we might run out of screen. So we go. So I think here in image.h, we'll just hard code the size of the screen. So we'll say that width has got to be, so it's got to be x plus image width. Let's just do it longhand and maybe we can optimize it. So we'll go x begin is at x. uint32 xend is going to be at x plus image width. The C, yeah, C has got min and max, right? C min. Oh, it's got f min. Does it really not have a min function? Do I have to? Do you really want to make me do a conditional just to figure out what a smaller number is? No, okay, they're part of C++. They just didn't think they might need them in C. Jeez. All right. So we'll go. So X is greater than screen width. Screen width X. Because, oh wait, because X can, no. God, alright, because now we've got to worry about like negative numbers. Because like in theory, right, we want, basically what we want, right, is we want to be able to like crop the coordinates to the window. And like, okay, C clip function. Has someone written one of these? Because like, yeah, OpenGL's got it. Like, it's just got the clip function, which is C clip function, which, you know, bounds it at like lower, you know, lower and upper. Yeah, it does effectively this. Or STD clamp. C clamp function. I'm just gonna like crib an example and okay, it's basically that. That's fine. We'll make a little inline for it. I'll just go so we'll go and yeah, it's basically just doing what we were doing here. So if we go like, if I is greater than A, then return I, else return A. B, then return B, I B. Oh, whoops. So we can then go, X begin equals clamp X 0 screen width. Oh. That's gotta go in it's gotta go into here, doesn't it? It's gotta go into here. So, done all that. X plus image width. Okay, but this will still have an overflow of 1, won't it? So really, this should be I is less than B, I, B minus 1. I think that'll do it. So if, like, if it's 319 pixels, then that'll work. But as soon as... But yeah, as soon as it hits 320, then it will become 319 again. Yeah, okay, that's good. Okay, so now we have this. We can then change this from like y begin to... Actually, no, we can't. We can't do that. So we'll do that, and then we go VGA. So like what we kind of want. So we'll say off equals yi plus yeah, because this because xy, yi and x are in image coordinates, but we want like VGA coordinates, which is going to be y begin. And then, yeah, again, we don't want to do this. Yeah, so we go un32 t height equals y end minus y begin. I think that'll work. And then, okay, that's good. So we can go... No, that doesn't really... no, okay, I've made another problem. Which is that... What have we got? We have in screen coordinates, like, where we want the image to be drawn. But we don't... okay. What we want is like an indication of like where in image coordinates it should begin and end, and those are no longer like width and... Okay. This is all the math that normally like STL does for me, so I'm gonna have to... It's a real... Yeah, it's kind of a... It's kind of rough. It's kind of rough having to like think for yourself. Not sure if I care for it. Oh, but yeah, we'll okay. We have x begin and x end. That's where we are on the screen. Do we need that though? Yes. Okay, because... So we can go... Well, okay. All right. Yeah, because like the issue is that we now got to like change that back into like image coordinates, which is harder. Because like yeah, okay, all right. So we can go x uint or we just go int x start. Oh, and these should all be ints. These absolutely should all be ints. Okay, and that's going to... Okay, now we're converting it back to image coordinates, which means that is going to be the number 0 minus... okay, so easy. We could just go, is x less than 0? Then it's 0, else... Oh, wait. Oh no, more correctly, is x greater than or equal to 0? If so, then it is 0. Else... it then becomes... Oh, Mamu saying you should always use sign unless you're doing bit ops on them. Yeah, probably. Yeah, no, I agree. It's when you're doing like cropping rectangles in the XY plane, yes, you'd want to use signed. Oh god. All right. We were doing well. We had like a nice kind of momentum going until we had to front into this. Yeah. And we have like the width on the screen, but what we don't have is where this is in. Like ideally, right, we'd have a nice... Oh wait, no. We've got it. We absolutely have it. So the start of the image is going to be x begin minus x. So if that's like a negative number, then like, okay, can I draw this? This may be a mistake. But, so here we go. We've got the playing field, or we've got the screen. Then on top of that we have a sprite which is being rendered like just off the corner, which is bad. So this up here is x, y. And what we want to find out is how much, like this area inside here, like what is actually, which dimensions relative to the image is being drawn on the screen. And we've got the coordinates here, 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 and here. So it feels like we should be able to just okay. Oh my god. Yeah, so if we compare this coordinate. So let's compare that coordinate. And we'll say that int x image begin equals x is less than 0. If so, then it is... If it's less than 0, then it is 0. Otherwise it is... Oh, so... Hey, Sev. Mercifully providing some hints about rectangles. But I think we've got it. I think we've got this. So do that, remove if it's less than 0, then it's that. X is greater than or equal to. There's probably going to be like some broken edge cases with this. I might steal it from someplace competent later, but for now we'll go X is greater than screen width, or X is greater than or equal to screen width. If so, then we go screen width -1, else X. Oh wait, no, it will be... Sorry, it'll be X plus image width is greater than screen width. Y plus image height is greater than or equal to this. Plus image height. Okay, and then we can... Actually, no, we don't even need to worry about the end. We just need an offset. We just need an offset that converts these screen relative coordinates to container level coordinates. And I think we can just do that with the begin. Oh no, that's still kind of sleazy. Oh wait, no, it's not. We don't have to worry about, like, width is already being dealt with here. Width and height already dealt with. We only have to worry about if we need to start slightly earlier. So I think that works. So then we should be able to go this and this. Yeah, we deal with the width after this. Like we're just worrying about the start offset from the image. Okay, and then we go, so this is, yeah, okay. Why, so from image coordinates we start from, like if it's less than 0 we actually want minus y.
Yeah, and actually an uneven width is something nice when eating it. It gives a nice texture.
Yeah.
Yeah, that makes sense, because like the more pixels that you're off this way, yeah, we want an offset like that. Okay, good. So go y image begin yi is less than or equal to height. Then we can get rid of that, and then we go x image begin. This is gonna like probably blow up, but I don't care. I don't care at this point. I just want to see crap on the screen. Also, there's no memory protection, so what's, you know, it's not gonna crash. It's just gonna look weird. Yeah, I think that sorts us out. And then finally we blat, you know, dump the crap into to video memory. So doing that would be VGA YI So this would be yi times pitch, image pitch, plus maybe I should store the pitch as a power of 2. That's okay, doesn't matter. Image dot xi. Okay, so we have this, and then okay, then we just use yeah, we could use memcopy, I suppose. Sev asked a question. I wonder why not use the Allegro library? Because Allegro only supports, well, it uses Visa for the graphics. Like, part of what I kind of want to do, right, is eventually I want to also use EGA and CGA, which means kind of like using the hardware directly. Also, Allegro is, I don't know, every time I've looked at Allegro, it's given me a headache. So I'm biased. So no, we're doing things the monstrous way for a reason. Not a good reason, but a reason. Yeah, I suppose Mad Moose mentions, you know, Mad Moose is right. We probably should be using memcopy. That would be the good way of doing it. So go memcopy. So it's destination first, isn't it? Yeah, destination first. So it'll be VGA plus something, image data plus something, and then the width would be this. Plus yi times image pitch plus xi. Oh wait, no. Yeah, that'll do it. Alright, and then we just gotta figure out what the maths is for the VGA. So screen space. So screen space begins with x begin, okay, and y begin. So we'll go y okay. Yeah, I think that'll work. Oh wait, yes. Yes, it should still work because yi is all image relative, and then yeah, okay, that's how you get screen relative. Okay. Int x square equals x begin plus xi. Then we can do a horrible bit shifting thing, taking advantage of the fact that the screen is exactly 320 pixels wide plus call to unspecified. Oh, because I need to void it. Void pointer. Did I... Hang on. How am I doing memory thing wrong? Yeah, Sev, so like the plan will eventually be, like, we're just doing like crappy prototyping to begin with. Like, once the crappy prototype works, then we'll split it out into like a swappable kind of driver struct. But we, you know, first things first, we actually got to put something to the screen. So mem copy. Okay. Void dest, constant void source, size t, count. Okay, what have I cocked up? Is it the last one? Do I need to make this size t? Oh, is it because it's const void? Oh no, even dumber. Okay, even stupider than that. I just gotta... It's in string.h. Okay, that'd be why. So, it probably shouldn't whinge if I take the typing away. Okay, but we now have a blitter function. So let's see what it does. It's probably gonna make a big mess. So we'll say I do 100. Video blit image, and move this down to here. And then we'll do it about 10 frames a second, and we'll do 1,000 of them. Okay. Well, it didn't define it. Oh, I included it in DOS.h, I thought. Screen width, screen height, yeah. Oh, I did, okay, but I didn't include it in DOS.c. XI. Oh, where did I use XI? Oh yeah, we don't need plus yeah, there we go. All right. Better strap in. Let's see what happens. Hey, there we go. Got a crash. Got ourselves a little crash. I guess yeah, I guess the Oh, Mad Moose says June is dynamically loaded graphics drivers but only ever ship with a VGA driver. Oh, so that's a missed opportunity, because, you know, it's only, you know, Frank Herbert would have liked it in the original Hercules. Okay, now I think to figure out like where it went wrong, what we're going to need to do is What is it? Oh, I-586, MS-GDP, address to line.
Tony Ferris mans this console for driver Chipper Dunn.
Okay. Yeah, we just got to figure out where the instruction pointer is at. So 2070. Oh, somewhere in... Okay, somewhere in the CRT code. I hadn't really thought about debugging until now. I just kind of assumed that we could, like, sketch it. Alright, what if we kind of stack the deck and make sure that it only the numbers are kind of nicer? Well, you say that, Mad Moose. You say printf to the rescue. The issue though is that we're in mode 13H, which means you can't see the printf, which is why on my to-do list I have set up a serial link so that we can get those messages. Which may be the next option. Actually, hang on. Like, does it? So it's a page fault, right? Does it show where? Does it show where that we screwed up? Does it? Oh, 690F3. Okay, that's the other thing. That's right. 690F3. Oh, and I'm not building with debug information, so of course we don't get those lines. How about if I turn on debugging information for the terrible code that I write? I'm sure that like the Sping people and the Mini-Z people, they're all good, but we don't have the luxury of being clean with our code here. So I'm going to turn on debug symbols. And then we run that again. It'll crash again, this time with a different one of those. 113? Okay, so we know... Oh, what? That is interesting, because that was working before. Like this is kind of like the old bait. I don't know. This is some way of in DJGPP to exposing conventional memory to it exposes conventional memory to the 32-bit address space through some kind of terrible magic that I'm not aware of. How about if I move like this to the very start and see if that makes, because like I vaguely recall this needs to be like one of the first things that you do, but we'll see. No dice. It is still. Did that Oh yeah, no, I changed where I called it from the thing. Right. So I mean, okay. So we're not even getting to the fun bit. We're dying at like step 1, which, okay, maybe this is a mistake. Maybe we should be like, because there are other options, right, for accessing the VGA, registers through protected mode. It generally involves buffering them through some other code, which is considered slow. Yeah, this is what I kind of looked up. It says call it at most once per frame and preferably once at startup. Screen is an honest to God pointer that you can memcopy to and from. I mean, I'm not surprised that it doesn't work. I'm absolutely not surprised. But the I guess we can use far pointers like that. That's probably safer. It's probably safer to use far pointers. And like on like in DOSBox, like far pointers are essentially like the same cost. And we've already kind of agreed that we need, like, we're aiming for a Pentium, so maybe it's not a big deal. Maybe we can just get away with doing that. I mean, that's far poke. I mean, I really like the concern I have though is that if we do that, if we make it a near pointer, if we make it a far pointer, then I'm not sure if we can just do things like memcopy on it, which would be a massive shame. This function enables near pointers to be used to access the DOS memory arena. Sort of. When you call this function, it'll return non-zero if it has successfully enabled near pointers. If so, you must add the value conventional base to the linear address of the physical memory. Yeah, okay. We're doing that. Like we're adding that afterwards. But the problem is it's crashing like in there. Like what? Is it because like of one of the other libraries that we've added in? Is that why it's doing it? Like, what about if I disable everything except the video shutdown code? I think that I want, okay. Progressively adding things in. So I'm just gonna create the image. Yeah, okay. That still did it. How about if we like shut down the video code properly? Will that cause a crash? No. Okay. What if I free the image? Will that offend your sensibilities? Okay, freeing the image is apparently bad. But even so, hang on. So, no, like 69026, is that actually main C.23? Did I wasn't reading it properly. I wasn't reading it properly. So I thought it was DOS.c. So it's actually, no, this is fine. You're absolutely fine doing that. No problems. Actual issue is in here. Yeah. DJGPP conventional base can change after malloc and free, so you need to redo that part for real. Okay, that's does it? I guess we just got to do it every single time we access some video memory. Okay, that's good to know. Thank you. Thank you for avoiding the bear pit. So we'll go. I guess we'll just go I think I saw, yeah, I think I nicked some example code which just added it the once, but you know what? It would not surprise me if that does change after memory management. So we'll play it safe. We'll make a copy each time. But okay, it helps to read the error message properly. Is the lesson I'm taking away from that. And clearly my deallocation code is flawed in some way. But how? What could possibly be wrong with it? You must recalculate the screen pointer every time you enter this mode because DJ GPK conventional base can change when you malloc new and other misc stuff. Hey, okay, fun. Alright. Good to know. Very useful advice. Starting to get an understanding as to why some DOS games crashed a lot, especially like DOS games made by beginners. 2518. Image C84. Okay, which screw up and that was mine. Okay, it was freeing the data pointer. Interesting. Because that should be... Okay, I allocated that with calloc, and I'll even put in a little printy printf. Actually, no, I can't because I'm running graphics mode. God damn it. But calloc is got to be done with free, right? Yeah, deallocates the memory space previously allocated by malloc, calloc, aligned alloc, or realloc. So I guess the... Okay, let's go. All right. Well, let's just to be hacky. What if we just tried what if we just tried this without running the code that we know is broken? Like if I recall correctly, it'll crash earlier, but at a different spot, which would be at 69123, which is main.c line 19, which is at usleep. So maybe, yeah, okay, maybe we are kind of scrubbing outside the lines, and that's caused a page fault. Bollocks, alright. Okay. Okay, so 2080 is line 49 of DOS. Which would be okay, that's interesting. Why is it failing on clamp? Oh, because it's trying to because the image pointer that's being given is garbage. It's got to be that, right? Like that explains everything. That explains why the destroy image doesn't work. And when it tries to dereference width, then it dies. Okay. We've got... Okay. So something is happening here to not give us a proper image structure. And I want to know why. So we'll turn off. So we'll turn off the video init code. We'll turn off all of this. We'll just have the image code. Okay, image test.png is not paletted executing. Okay, and then because we returned a null pointer and we're not checking for a null pointer. Okay, we absolutely could have like solved this with like better checks. If not image return printf warning tried to blit nothing yet dingus. If that's really it, I'll be kind of amused. I mean, yeah. I'd say C is regrettable, but I mean, it's C++. C++ is a proper mistake. Like they knew what they were doing. They knew exactly what they were getting themselves into. Alright, so we'll go if image return. Why did it not occur to me to check if the pointer had something in it? Okay, there we go. Much better. So, why? Oh, that's right, because it was failing the check to check if it was like the color type. Yeah, it's gonna be busy doing that for a little while. Printf works so long as you don't want to do anything in the interim. Oh yeah, I said we were gonna blit a lot of things, didn't I? I said blit 1,000 images. That's probably too many. Anyway, get rid of that. So what type does it think it is? Okay, it thinks it's image number 2. Oh, sorry, it's type 2. What is type 2? Why is type 2? How is type 2? SPNG color type true color, SPNG color type index. Like, did I not write an indexed image? This is not save as. Sorry, export to test.png. Export as test.png. Replace. Automatic pixel format. I'll be a little annoyed if it does not. Oh, it's probably because I picked 8 bits. Yeah, because I picked 8 bits per channel RGB specifically before, didn't I? So it probably wasn't a paletted image. But hopefully now it is. Expected EOI got 1. Okay, well... I get the feeling that maybe I should just comment out the blitting bit. Because we're not... Until we actually get like a working image. Okay. And probably the video switching code while I'm here. So we can actually read what's going on. Color type 3. Expected EOI got 1. Oh, I see. Okay. SPNG Iron Val. That's what we're getting. So let's put in a little little helper. Does it actually read any road numbers? No, it reads nothing. So it's failing at SPNG get row info. So if the context is null, or if the row info structure is null, or if the state is not at decode. Okay, I'm guessing that we're not reaching that. We're not reaching this goal yet, which is decode init. And that happens after you call our very good friend SPNG decode image. I see. Okay, so we need to set that up. We need to set that up first. We need to set up a buffer to do that. How did the thing do it? So there's decode the image in one go. I don't really want to do that. I want to decode it progressively. Yeah, I want to do this. This is what I want to do. And then format. What is format? I want whatever is in the PNG, because we know that it's going to be we know it's going to be there. Okay. There we go. Okay, I think we've got a valid pointer now, which means if we uncomment all this junk, we're no longer going to be called a dingus for dreaming big. Although, yeah, I say that. It's not crashing. Oh, but look at that. Oh, we got one. We got one picture that was on the screen. Great. Okay, let's not use rand. Let's keep things like predictable. Okay, so my math is off, clearly, because it's just splitting one copy of... Oh no, so there are two things wrong, right? One is that the image is only... what's it called? We're only splitting half the image. And... yeah, the indexing seems to be a bit cooked. Okay. It would be so okay. We could there is a kind of a bad way that we can do printf, which is we can just write to a file. That would save having to get the serial port working for now, but I'm almost tempted to think that we should just get the serial port working to see what's going wrong. I'm also kind of curious as to like what these colors are, because these aren't in the... Some of these don't look like they're in the stock. Like these aren't EGA colors. So where's it? Wonder where it's getting them from. Oh, is it also being quite, like, is that 62 high? Yeah, okay, yeah, the height looks okay. It's just the width that is being cruelly chopped down. Oh. So it occurs to me, how many colors we got? 1, 2, 3, 4, 5, 6, 7, 8. What if the PNG decoder is stashing at 2 colors per byte? That would explain why the width is... That might explain why the width is off. Oh, we can check. We can check. So I'll move this back into one continuous blob so we can comment it out easier. So back in the image decoder, I is less than... think this will work. Maybe. Sort of. Sort of done. Oh wait, no, it, if only we had more text. How about if I crank the cycles down to almost nothing? No, I'm being silly. I should add in a sleep so we can actually read it. Yeah, okay, so you see what it's doing here. It's storing the colors as packed, yeah, because like, yeah, it's storing 2 colors per byte, which is clever, but also not what we want. What we actually want is, we want 1 color per byte, because that's what's going to keep us sane. Partially implemented C documentation. Okay. There's GA8, GA grayscale. Okay, maybe this is something that we have to do ourselves. I hope it isn't. I really hope it isn't. Because that would mean doing 2 buffers for every image. Where's that? Okay, let's load in like. Okay, so we load in our new chunk checker. Okay, the bit depth is 4 bits per pixel. That's, yeah, that's where we're kind of getting done. When really what we want is 8 bits per pixel. Okay. Oh, and that, okay, yeah. So... okay, which means that we're going to have... Yeah, so it means that if we index an image and there's going to be like less than 8 colors, then we've got a... Oh, sorry, less than 9 colors, then we've got a problem. Because it'll try and compress the data to suit, which is honestly what it should be doing, but it just does not help us. It does not help me. It does not help me at all. Yeah, okay, so bit depth. Bit depth is 4. And if bit depth is less than 8, then we set bytes per pixel 1. Else bytes per pixel equals bit depth divided by 8 times number of channels. How bad if I like just picked one of the other formats? Like, we don't want RGB8. That sounds like a bad idea. But how about like G8? Oh no, that's with alpha. It's like, how about just G8? Which then means pixel size will equal 1. Can we format G8? No, didn't like that. It didn't like that. I guess maybe we have to do our own expansion operation. That's a bit weak. So how would we, I mean, we have two options. We can create a temporary buffer just for decoding a single row, and then we can go ahead and expand it out into into the real thing using a loop. Yeah, I'm feeling amenable to that idea. That's probably the most hassle-free way of doing it. So we'll change that to, yeah, format PNGs in, all this. I'll say byte row buffer equals calloc, and then the actual size that we'd need for it would be about image width times like one of these fields, yeah, bit depth times IDHR bit depth. Actually, no, it'd be times 8 divided by bit depth. So then that would mean no. What would that mean? So like it would it be times bit depth divided by 8? You know what? It's just a temporary buffer. It does not matter. Absolutely does not matter that we get like the width right. We can just make crap up. We can claim. We'll just make it as big as the image. And then we'll just go free row buffer, and this will decode into the row buffer, which we know is going to be of size image width. And then for the actual int I equals 0, I is less than or equal to image width divided by IDHR bit depth. Okay, that works. So I row size. Oh, I get it. Okay, so then be, yeah, so then be I, row I equals row buffer I times 8 divided by I HDR bit depth. Oh, and then we're gonna have to do like some shifts, some shift operations, aren't we? We can just unroll it. We can absolutely just unroll it. So we just go switch depth case 8. Mem copy row buffer break. Bit depth. Case 4 break. Row I equals row buffer I divided I shift by 1. We'll just unroll it. It's fine. Yeah, I guess this is why people like Allegro, huh? It just kind of deals with this stuff for you. Honestly, like, libpng would probably deal with this stuff as well, but too late. We're not going back. And we may as well make 2 and 1. 2, 4, 8. Is it 3? Yeah. Okay. And then that would be... Seven. What was the... hang on. My mind's going a bit. 255. Yeah. OB. CO. CO and 3O. Alright. Yeah, I think that'll work. Much better, much better. Look at, yeah, look at all those 5s. Look at all those 5s showing up in the right spot. Yeah, that's good. That's very good. Well, now that we know that, we can get rid of this. We can get rid of this. and we can turn on the video code. Yep, any second now. Any second now this will finish drawing to the screen and we can keep on going. Okay. Hey, look at that. Okay, that's good. That's now using the correct palette indices. Those are all EGA primary colors. Next mystery, why is it not bouncing around the screen? Why is it just staying in that corner? I don't like it. I'm guessing because
the best New Year's gift they could get. Congratulations, Grand Chef.
Yes, this is indeed the best New Year's Eve gift that you can get. We'll see if we can get anything positive out of that. Oh, I forgot to put line breaks in. Yeah, that's kind of a mistake, huh? Hang on, we'll do it properly. We'll add a line break in. Also, I noticed that I guess that like DJ GPP must add in like the carriage return for you. Yeah, alright, so it's... Yeah, those dimensions like look correct. Like they're starting up in the top left corner and... Okay, maybe... I'm guessing... Yeah, this isn't working. Like, those absolutely should not be negative numbers. Oh, because I've got around the wrong way, I think. Yeah. So it's just buttressing up in the top left corner of the memory, top left corner of the screen. Hey, look at that. Okay, and we get it. Look, we can even see how the text buffer is affecting like stuff being. Hey, we're gonna see that again. Okay, so yeah, it must be shifting the VGA memory like up by, you know, whenever it scrolls the text, it just must be like shifting the entire contents of VGA memory up, which is why it goes from like a diagonal line to, you know, this kind of little offset. But it seems to be working without crashing. Maybe we're overriding like other valuable parts of memory, but I mean, it seems fine. Seems okay. Okay, so then if we go back to here and we put in like some random numbers. And we build that. We got it. Yes. There we go. Okay, I'm just gonna bask in this for a little more, because we had to jump through a lot of hoops to get here, but we got it. We got our first triangle on the screen, and that feels like it's worth celebrating. Try it with negative X and Y. Really, Mad Moose? You want to ruin it? You want to ruin it and see what happens if we draw off the left-hand side of the screen? Well, actually, no, speaking of, like, it looks like the clipping is working, because otherwise these ones that are being drawn off the right-hand side of the screen would have wrapped around here, but they have not. So I guess we're cropping the left-hand side. We're cropping the left-hand side good. Oh, sorry, the right-hand side good, but okay. We'll do it properly then. So if we what are we gonna do? We need to, so it'll be screen width plus image width minus screen width plus image width minus image width. And that should give us full coverage. Oh. Did I do too many of these? Extra comma. Yeah, it doesn't seem to be kind of doesn't seem to be bleeding off the left-hand side of the screen, which is a bit problematic. So, oh, but that could be. Is that because maybe we need to like ensure that it's an int? So I've been bitten by this before, where coercion doesn't work. Nope, it legit looks like an issue with negative X and Y. So, what? So we need to turn this back on. Yeah, interesting. So we have some which have got like a positive number for X begin and Y begin. Oh, X image begin and Y image begin. So they should be off screen. Have I got this around the wrong way? We've got Y image begin and then... Yeah. But it should... no, okay, those are screen coordinates. Screen coordinates should always be X begin and Y begin. Yeah, I've doubled up. I've doubled up is what I've done. So I think that if we just went X begin and Y begin, because these are all, or rather, sorry. It's, yeah, X begin plus X image begin, which, yeah, would, but that's not quite right though. It's not quite right. Because, okay, this is, you know, X begin where it is on the screen. It would just be, like, I swear, it would just be X begin. Like, it would always just be X begin. And then... YI is... Does that look better? Okay, we're rendering stuff off the left-hand side, but there's also... We're also just, like, missing bits of image, but I don't know if that's because I've got, like, the debug spew switched on. Like, let me turn that off. Oh! Okay, I think we crashed DOSBox, so clearly... Oh, we crashed DOSBox hard. We did something really bad. We'll just double check to make sure that's not a fluke. Nah, we're getting kind of like weird cutoff bits. I'm not sure if I like it. Yeah. This code is problematic, is what it is. It's got bugs. It's got big bugs. But yeah, I think this may be like a job for me to go off stream and copy like a good clamping algorithm, or a good example of clamping two sources. I mean, yeah. I don't know. Maybe it'll come down to like writing a rectangle model and using that, but okay. So I'm pretty happy that we got graphics drawing. So we'll say add image loader, we've done that. We've converted to the display pixel format, and we've blitted a test image. What else can we do in the last bit of the stream? I think, yeah, for the last bit of the stream, I'm gonna quickly look up to see if we can get a serial link set up, because that'll save a lot of heartbreak. Just, you know, doing deep, you know, very useful for debugging, and I would quite like that rather than having to kind of fight with mode 13 for use of the screen. Okay, so DOSBox. DOSBox has this. It has the ability to like program the serial ports to be whatever you want, pretty much. And one of them here is like a direct thing, which then like under Linux, which is what I'm using, it turns it into a character device, or like a virtual terminal, which I'm guessing you can then hook up to like SSTerm, which is my, you know, simple serial port terminal of choice. It's like, I don't know why all the serial port terminal apps are so bad, but for some reason SSTerm, it's actually good. It does, it works, and it isn't, I don't know, like, I don't know, Minicom and all the others are just, there's just something wrong with them. They're just not good. They don't bring you joy. Okay, but serial, yeah, so what I want to know is, can we use libc to say, don't write to standard out anymore, instead write it to possibly a file struct, which could be a COM port. It's, I don't know, maybe actually let's rethink this. Let's go DJGPP COM port. Serial port. Is termios.h part of libc? No. You think that'll work, Bad Moose? Like, under DOS, can you really just like pipe with the angle bracket character like that? That seems too easy. That seems, I don't know. Seems a little sus. Like, I'm not like, does DOS even have like, I don't know. Like, I want to say to like, does DOS formally acknowledge the existence of standard out and standard error? Or is that just something that they added when they wanted POSIX compatibility for like Windows? Okay, MS-DOS serial port communication. I'm not, yeah. Yeah, Mad Moose says, there's a reason you still can't create a file called con on Windows. I don't know. I reckon by 2030, maybe you'll be able to make a file called orcs. But, you know, they've got their top scientists working on that, trying to remove the last vestiges of DOS. Okay. Cool, there's an entire book about this stuff. So what have we got? We've got Turbo Pascal, Free Pascal. Don't really want Pascal, I want C. Oh, apparently you can redirect standard out but not standard error in DOS. Did not know that. Oh, but we could just do it with, with this, and I get the feeling that we might have to. This is good, but I also don't want to be reading. I don't know. I don't want to have to like mode switch between Pascal and C. I just prefer to read C. Does DOSBox have the CTTY command? What is the CTTY command? like it does have the ability to kind of direct serial port traffic to a real terminal device or a real TTY device on your system. So I think the plan was, like, my plan was just to like create a virtual one of those with like SOCAT and then attach SSTerm on the other end. Oh, okay. So this is one of, okay, this is a, okay. Products, Microsoft Disk Operating System. The traditional method of writing and writing to the serial ports is done through, okay, so there is a DOS interrupt for that. In MS-DOS versions 2 and later, the handle-based read file or write file device functions can be used to read. Yeah, so there is a, you know, you can like reach out to the DOS BIOS for this, but that makes me kind of wonder, does DJGPP wrap that? Or at least kind of provide an equivalent? Because it wouldn't be the first time that something like that has happened. Because I mean, like, you don't have to like use DOS IO to write stuff with like fopen. That would be insane. Like, that's all handled by GCC. But I'm not sure if the same thing would apply to like IO ports. DJGPP COM1. Like, it doesn't have to be pretty. All I need is just a way of writing junk to COM1 and COM2. Well, actually no, we'll use COM4 because COM4 doesn't conflict with anything. But I refuse to believe that no one has asked this question before. There we go. Look, libc mentions COM1. Okay, BIOS serial COM. Okay, this wraps the BIOS support. That's okay. The COM port doesn't have to be very fast, so I'm more than happy like using what's it called, like wrapped DOS junk to communicate over the COM port. That's fine. I'm very, very happy to do that. So maybe we can do that. So it would just essentially be like BIOS serial COM uses int14 to provide serial communication services. Command argument can be set to one of the following. And yeah, it's not POSIX portable. Which actually makes me wonder, like, if they've got like a helper for like this particular routine, I should probably change, because I think I've got like a raw I put in some raw interrupts for doing things like doing the mode switching. Like, maybe I should just use the nice documented DJGPP wrappers for that. Like, we'd still be, you know, we'd still be kind of like doing direct memory stuff for like the VGA registers and that, but like this doesn't look very nice. Like, if there's like a nice kind of libc wrapper for that, we should probably use that. Oh no. Okay, maybe maybe it's just used for... Okay, maybe it's just a one-off. Maybe it's just they added a nice serial COM function for that reason. So yeah, like, there's a bunch of stuff for like DPMI, there's all the other standard library stuff. BIOS functions. Okay. Anyway, that's for later. Let's make some serial port stuff work. So we'll go void write to console out. Now the disadvantage here, right, is that
similar to a serial?
Not quite. It's steamed once.
Okay.
Like the disadvantage here is that it's C, and I'd really like just like printf and stuff to just work and use the serial console instead. Like that's, yeah. Because what have we got? We've basically just got like a command, a serial port, and then like what's the data? Data argument is ignored if command is set to com receive or com status. The data argument for com init is created by combining one or more of the following constants with...
Gavin, honey, help Mommy pick a cereal. How about alfalfa beds?
Those suck! I hate this store!
But sweetheart, Mommy...
I hate you, too! I want to live with one of my dads!
Dang. Lot to unpack there. BIOS... Okay. Okay, so this is just for setting up the COM port. This isn't actually for, like, streaming to and from the COM port. Oh, it sends and receives single character? Oh, okay. This must be like a custom API that like Microsoft implemented for like Microsoft C, and then DJ GPP just made a copy of it. Unsigned integer because the BIOS serial convert also uses the data parameter in initialization status checks. For more details on serial programming, communication programming in C, see the C Programmer's Guide to Serial Communications by Joe Campbell. Okay. Is this going to be like one of those books that only exists in a museum? God bless you, archive.org. Publication date 1987. Okay, great. Good start. Because, like, really what we want is, like, a file, like, handle. Because once we get one of those, then we can point standard... You know, we could tell printf to start using a different file handle, I think. And then yeah, it'll just work. So... Oh my god, it's 678 pages. Gee, where's the... Okay. $178 pages. Come on, that seems excessive. Yes, we know about that. We know about that. Okay, this is... Oh, it's just talking about like all the different serial protocols as well. I don't care about any of that. I just... I specifically want information about DOS. Is that... Wait a goddamn second. The COM port is a file in DOS, isn't it? Can we not open the COM port as a file? DOS open COM port as file. Like, can we... Like, if we can get a file pointer for a COM port, then we're basically... F open? Because, like, yeah, that's, like, the whole reason why there's that stupid file system thing, right? Because there's always, like, COM1 and always COM4 and always AUX in the damn... in the same path, right? Is it really as simple as that? Is it really as simple as, like, opening it with fopen? Interacting with the serial port using the C functions fopen, fread, and fwrite. Yeah, there are some options, I guess. Like the one downside of like doing it all ourselves and using like the DOS API means that we don't get we can't just use like printf through a COM port, which would be ideal. Okay, special reserved device names in DOS. You could do something crude like this: copy con myfile.txt and copy from the console into myfile.txt. I suspect you can interact with the modem, a serial device through the COM port, but copy is outlet. Okay, but that's doing things with just like file copy tools. That's wrong. That's dangerous and wrong. But okay, but what if okay, you should be able to use printf to the COM port with COM1 on the command line. Okay, well, echo, I suppose that's an option. So if I were to, why don't we, okay, so socat virtual serial device port. So let's set up a virtual serial port. Let's join it with DOSBox and then see if we can like echo stuff to COM4 and see if it comes out the other end. And then if that works, then we know we're onto a winner, and we just got to figure out a way of we've got to figure out a way of routing printf and everything through it. Okay, do I have socat installed? I don't have socat installed. There we go. So socat dd pty raw echo 0 pty raw echo 0. Okay, so we have one end which is dev pts 55 and one end which is dev pts 56. So if I were to attach SS term to... Oh wait, hang on. SS term, what are the options? And if we check it, I guess we go like 9600 baud, I think is the default. And then... this. And then on the other end, we should be able to go serial for direct real port PTS 56. Oh, type must be one of the following. Disable direct dump. It is. Direct. Okay. Oh wait, did I do... Oh, I did 56 twice. I did 56 twice. Okay. Right, so... And then if we go echo what... And we pipe that to COM4... and it... Okay, it just went up and died. But I'm sure it had a good reason for doing so. Yep, a real good reason. A real good reason, which makes perfect sense. Oh, but I don't have debug symbols, do I? Yeah, shell redirect output to COM4. And it tried to do that, and then it, I guess, crashed in a big heap. But... Okay, well... Alright. So, I think I know what needs to be done there. I need to go through, I need to build DOSBox staging with debug symbols so I can see where it's crashing and why it's crashing. It'll probably be something to do with the name of the device, I'm betting. Although, we can... Hang on. Dev. And if I... Where was that, where'd that pipe go? That was here, wasn't it? Yeah, okay. Dev PTS. Serial for direct real port. And then we change this to what? Echo what? COM4. I mean, okay, nothing came out the other end. But yeah, nothing came out the other end. I wonder why though. I wonder why that is. It's like right, yeah. So like from the 56 end, like data is getting written. But why? Oh, maybe I need to change it to like, oh no, so direct is always, sorry, direct is always real port, or rather like the only one that supports real port is going to be direct. Can we set the rate? Can we set the rate of, Because, like, I mean... I could imagine that, yeah, if it was the incorrect rate, then maybe, like, stuff wasn't coming out the other end. Oh, port 4 errors. Yeah, okay, so it's a mismatch. It's a mismatch of, Wait, so does that mean if I, like... Yeah, okay, so there is communication happening. There is communication happening that is, I'm guessing, far too fast. DOS default serial rate. Like how many boards is that fault? I could have sworn it was like 9600. But that could be, I mean RX overruns, right? That would imply that it's getting the packets but it's not processing them, which is true. We're not doing that. We're just receiving a bunch of junk and nothing's happening. But why Why is this not showing up on, Why is this not showing up on the other end of here? Implies that it's trying to do something, but it's not quite succeeding. Like, I guess... yeah, that's the thing, like, even if it's the wrong rate, I feel like it should be working. But... Anyway. Yeah, it's getting late. I'll probably wrap up the stream there for now and just, again, enjoy. Oh wow, this is taking far too long. Oh, and it's crashed. Excellent. But you know what? It doesn't matter. You know why? You know why? Because we can freaking do this. We can blit terrible things to the screen with a little bit of accuracy. Not a lot of accuracy, but some accuracy. Start BPS seems to be the option. Okay, we'll give that a shot. Serial. So if I got serial 4, direct, start BPS 9600, and real port. What? Oh, and I can't shout when I'm saying direct. Okay. So we've done that. We've got our serial terminal open. Echo to COM4. I can still make it angry by like sending data from this end of the serial pipe down the thing, but yeah, it's there's gonna be something going on with the DOSBox side of things. I'll have to like download. I'll have to like I'll have to rebuild DOSBox staging, figure out what's going on with the serial redirection code, and yeah, like then the idea would be that like every time we want to run this, we just start up DOSBox with like a script that turns on the serial port and everything, just to make it nice and easy. But I suppose that's not today. But anyway, I'm pretty happy that we managed to kind of like cut through like most of the nonsense to do with graphics, or at least like blitting graphics to the screen. That was going to be, you know, I was expecting that to be like a lot more hassle than it was, so it was kind of nice that we got that done. All right, I am going to check to see who's on. Who's on? Oh my god, here we go. Okay, sorry, Good Pete is playing Thunder in Paradise. He's playing the long lost DOS port of the Philips CDI Thunder in Paradise game. So yeah, we're going to raid Pete. So please say hi to Pete, everybody. As soon as I get this sorted. Yep. So I will continue beavering away during the week, but yeah, next week. So all this month, I think we're just going to be doing like DOS game engine streams. So, but yeah, I'll see you next time. Good to have you all on board. Bye.